And now we will move on to step 6, which is storing objects in a database. Basically, it is not an integral part of this overall OOPS concept, basically, but it is very important to do this, or else whatever you do will not be stored anywhere. So that's the reason I have added this part also inside this. Actually, this complete 6 steps completes our object oriented programming system that we follow while working on big projects. So at this point, our work is almost complete. You can see the complete script. You can see the complete object-oriented program with the display tool also. Okay, and here you have a testing. Now we know we have a two module system that not only implements our original design goals for representing people. Those are two, one is person, other one is manager, but also provides a general attribute display tool we can use in other programs in the future. So here you can see this is that display tool. By coding functions and classes in modules, we have ensured that they naturally support reuse. And by coding our software as classes, we have ensured that it naturally supports extension. Although our classes work as planned, though the objects they create are not real database records. Do you feel that or not? Yes, that is, if we kill Python, our instances will disappear. So they are transient objects in memory and are not stored in a more permanent medium like a file. So they won't be available in the future program units, whatever instances you are creating. So now what we can do? Now the question pops in our head is how to make them permanent. So we have a savior, we have our hero with a Python feature called object persistence. This feature is known as object persistence. Okay, so making objects live on after the program that creates them exists. As a final step in this tutorial, let's make our objects permanent using object persistence. Now, object persistence is implemented by 3 standard library modules available in every Python that are available in every Python. Those are the first one, the most important one is pickle. Pickle, what does it do? It serializes arbitrary Python objects to and from a string of bytes. The pickle module is a sort of super general object formatting and deformatting tool. Given a nearly arbitrary Python object in memory, it's clever enough to convert the object to a string of bytes, which it can use later to reconstruct the original object in memory. The pickle module can handle almost any object you can create. For say lists, dictionaries, nested combinations thereof, and class instances. You say it will do. The next important one is DBM. What DBM does is it implements an access by key files system for storing whatever strings that were created from the objects using pickle. Now what we have is a shelve. So what shelve do? Shelve stores the strings under a key in a DBM file. When later loading, shelve fetches the pickled string by key and recreates the original object in memory with pickle. The shell module provides an extra layer of structure that allows you to store pickled objects by key. So shelve translate an object to its pickled string with pickle. So to put it in a simplest way, what pickle does is pickle picks the objects. It may be a list, a tuple, a dictionary, int, float, complex. It may be anything, a nested list. It picks that object and it will convert that object into string. Once it is done, then it will be taken by the shelve. Then the shelve comes into the picture. Shell shelve takes the converted strings and stores it using a keyword in a dbm file in using a database management dbm module. And finally, when you call back the same object, shelve comes into the picture. It will fetches that wherever, whichever location it is there, whichever location that object was stored in a string format, that will be fetched by the shell using key, and then it gives it back to the pickle. Then the pickle will convert that string object format back into the original format. If it is a list, it is a list. If it is a dict, it is a dict. So like that, the three coordinate together and they make this storage possible. In this, the dbm module, the purpose of dbm is to provide a system to store the data, and shelf is a storage space. It is a layer. In that layer, the converted objects strings can be stored, and then pickle is, which is the starting point, which converts the main object into strings. Now we will see how we can use it here. From person, import just a code. Person is our file name. I will show it. Okay, just a minute. I have to open VS Code. Uh, Here it is. This is my complete piece of code. Whatever we have done till now, this is our complete piece of code. This is incremental test code. It is not important for us. From here, I'll just show everything in one piece of code. Let me bring it down. Yes. Now I think you are able to see the complete piece of code. Okay. Now let's see. So this is our complete piece of code. I have saved this piece of code in person.py. So now our module name will become a person, and it consists of all those things whatever we have discussed so far. Now I have imported person class and then manager class from that. Then I have created Charan one object, Hari one object, Shiva one object. Three objects. Charan and Hari are person class objects. Shiva is the manager class object. Then let's import shell from the standard library. Then we will use db, that any variable name. You can take any name. In that, using shelf.open. Open is a method of shell, and then add this person db string. Now for object we'll use a for loop, and then attach each thing to your shell and then close it. So this is how we do. So now we will go to the VS Code, Jupyter Notebook, and we'll see. Let's write a new script that throws objects of our classes into a shell. because shelve is a storage space inside a DB, that's database. In our text editor, open a new file. We'll call it makedb.py. So I have written that file. Let me show it to you. Makedb.py, somewhere where it is. Here it is. So this is how I have, these are three objects I have created. I have been creating the same objects in each video, so I don't need to explain this again. And from person, I have imported both person and manager classes. Now I have imported shell. I use this for loop to store all three objects inside the shell, and I have closed the DB database. So with this, we saved our instances inside a database. Let me save it and then go back to the Jupyter notebook. So storing objects on a shell database is done. Now let's import that file here so that we can see. Let me import. Yes, no issue. If this script has no output when run, it means it probably worked. We are not printing anything, just creating and storing objects. That's what happening. So when I import, no output, so it's working actually. So now you can look at the shells files if you want to, either from Windows Explorer or Python shell, but they are binary hash files, and most of their content makes little sense outside the context of the shell module. So now what we'll do is we will use some directory to view. So directory listing module files are present. Now we will import a module globe, and using that module we'll try to add. So this person is our main code file, that's oops code file. So with this we have made person.py and all these files. Now let's call person db.dir. Once you create that, you will get your database. Let me execute it. We'll see. So these are the three, because I'll just show you what objects I have created there. I have created the first object Mad, that's name of the first object is Sri Madhava Hare Krishna, and second one is Hari Keshava, and then Mahavishnu. These are all three objects I have created. So let me go back and see. These are all three objects: Sri Madhava, Hari Keshava, Mahavishnu. These are all three objects got saved. So now we will do small experiment. So basically just now we have imported this. That's why it may be working. Let's kill the Python. Let's stop it here and we'll close it. We'll close everything and we'll open it again and we'll see whether we are able to access that three instances or objects or not. Let me close it here. I'll kill from PowerShell and then I'll close it. I'll close it here. So I'll go back to the folder. Let me click shift plus mouse left, then show more option, window PowerShell, type Jupyter notebook, and it will open your HTML file using localhost and for 8888 port. Let me open that file. Let me come down. Here it is. I have reached. Let me execute this. Yes, without executing any cell on top, I directly executed this to get the person DB. So it is actually stored. It is permanently stored inside that. So with that, we have actually reached to the end of the most important session, that is whoops realistic run or whoops with real life example. So this is what the final code looks like. I hope you enjoyed it. you watch this video again so that it will be very clear. So if your concepts are clear in oops with Python, you can work with any other language, because oops by and large remains same, other than a bit of syntax varies. So that's why. So I hope you enjoyed this video. Just keep liking and keep subscribing and keep watching my videos and keep spreading to all of your friends so that everybody can watch and get benefit. Thank you, and see you again in another session.